Okay, so let's look at a guided playthrough where we will go all through those milestones to achieve those missions to advance you within your career. It's not going to be a prescriptive guide. I'm maybe showing you a few methods of solving this to plan ahead for your career program. I'm going to start with the scenario of the 1957, the light satellites, and I'm going to tweak the difficulty a bit. Um, Usually what I do for my playthroughs is for the ComNet, I'm going to require signal for control, and also I'm going to use the plasma blackout. Since the beginning of time, I don't know why I do this or um, what the benefit would be, but for RP1, I use Kerbalism for resource handling. Kind of forgot why I do this. Might be wrong. Let me know in the comments if you shouldn't do this no more. Anyways, but that's usually the only thing I modify for now. So we're going to accept this and we will be starting. So first thing we do is also for KOS, use the ComNet connectivity. So you can only use KOS commands when you actually have signal to your spacecraft. And we click this away. We don't want to show this no more. So the first thing we need to set up and see where we go from is we go to the administration building and we see we already have an active program, which is early satellites light. And it does have getting your first artificial satellite into space, scientific satellite, and everything else. So the thing is, what we do is we are going to create a launch system, a booster, a rocket that is capable of completing everything in here. So we keep this scalable, so to say, and not use a new rocket design for every other mission. And also what I'm going to do is for additional funding, I will accept already the Explain research contract, but we will not be doing this until like very late because for me it's tedious to design planes and do this. So first of all, we focus on the rockets, focus on the missions, and whenever we have downtime, we kind of start working on those planes. So we already could start with some administration. Just quickly go through this here real quick. So signs from transmission for now in the beginning, first 10 years would be good. Any other bonuses we might need? Let's go with this one. And then for the chief designer, in the beginning, we would like to have Golev, because Werner von Braun's Hydrolox, it comes in later. And also the speed of vessel integration, rollout recovery. It's going to take its toll, so I would take this one. So this is not very prescriptive. There are different, probably better ways of starting this. We'll just roll with this for now. So this guide should not be anything that is like super detailed. I have some other tutorials to go into this. I will refer to those, but it should rather give you a hint on how to use the game mechanics, the physics mechanics within the game to achieve what you want, and maybe give you a few insights. There's better ways to do a campaign, there's faster ways to do a campaign, but I would like to make this as much as beginner friendly as possible without going deep into physics, deep into details, especially when we come later to the Scopus missions, designing those antennas. I have a tutorial for that. We will just refer to this and use the knowledge we gathered there together and apply it here. Right, so let's get started. The first step would be we're going to the VAB, and usually there are a few approaches. So when I do a playthrough with the first rocket, so when you go like heavy satellites. If you don't want to start from the very beginning, sometimes I do the kind of like R7 style big rockets. But for now, we are kind of, I wouldn't say limited, but we already set in, everything has already been set into motion for us to use a rocket that kind of resembles the capabilities of like the early Thor rockets, the early Atlas rockets. Um, for an easy building and easy to use with MechJeb, I'm going to start with the first thing is I'm going to first design our not upper stage, but the second stage of the rocket. And we would like to have, so let's go with isogrid for now. We can check later if we can still go with the conventional tank, because it doesn't cost us any money to unlock. But usually I roll with isogrid because they're a little bit more expensive, but they're a little bit lighter. Really comes, I wouldn't say much of a flavor, but um, it depends on the rocket you build. But you if you have the funds, you will probably never go wrong with isogrid tanks. So this boy is going to be 2 meters in diameter, and then we are going to be near Earth. Easy avionics. Let's also put this to 2 meters in diameter. The controllable mass should be something like, let's go with 4 tons. 3 should be also okay, but 800 amount of battery, resize to fit. And then we need an engine. So that's an upper stage engine that we need there. And usually for this, especially with the technology we have right now, is I would go with the early HA10. You could, in theory, use something else. Most power playthroughs, I think, go for the XLR11 because it's reignitable. It's not as efficient, but yeah, it's in the end it's up to you. I just want to give you a direction and why I do what I do. Also, as you can see, I hope it's kind of visible and readable, but the engines and every parts are kind of labeled and categorized. And this is done with the additional add-on. It's VAB organizer, and there's also RP1 configs with it. And it kind of tidies up everything, so you don't have to search through all the engines if you know what category of engines you're using or you want to use. Right. So while we do have this stage now, I just want to size it a bit. So we need this one to be a high pressure tank, of course. Fill it in. Let's get MechJeb up with the delta V settings. It's up here, so it's 2 minutes 40. That's a little bit too much, I think. So let's dial this down a bit. We can't actually dial it down anymore. It's not that bad. So usually what I do is like, you could maybe just go with the procedural isogrid tank. Diameter. Put this in HP, fill it up, so that's a little bit. So we have a 2 minute of burn time. I want to go like 220, 226-ish. Yeah, 226 should be more than enough. And we also probably have enough. So right now we are at 2.38, so 2.4 tons. So we have 600 kilograms left of payload, and that thing is still uncontrollable. If we would go to 3 tons, let's check it out real quick. We still need some RCS, and so I would take the RCS tank, decrease the diameter to 60, I think, because it looks neater. We don't need anything much in here like this. So this is going to be high pressure as well. And then we are going to put some RCS blocks onto it. 4 of those here. Okay. So the question is, what kind of propellant do we use? And the propellant we use is going to be either HDP or nitrous oxide. Nitrous oxide is a little bit more efficient and has a little higher specific impulse. So why should you choose between those two if nitrous oxide is the more efficient one? So nitrous oxide is a gas. HDP is a liquid. Looking at this right now, you can see, so if we use nitrous oxide, if we use nitrous oxide as something like this here, we fill it up, we have like 3,000 liters in here. But if we would use HDP, remove all tanks, go for HDP, is only 160 liters or 14 liters. But looking at this right now, the weight is 2,430 kilograms, and switching this to nitrous oxide, it's 2,415 kilograms, so it's less weight, which means that it's not as volume efficient as HDP, but per kilogram of weight, it still provides more thrust. The question is, if we have small tanks, if you use nitrous oxide, do you run empty? If not, use nitrous oxide. If you keep on running empty, you can either get bigger tanks on there, or you could just switch to HDP and see whatever floats your boat. So with the early ones where we don't need much maneuvering, I'm going to stick to nitrous oxide because it saves weight while still having enough reserves left to, do some introducing some spin to the most upper stage, for example. Right. So now let's go to the booster stage, and for this one we can go multiple ways. So you could, in theory, leave this as it is. So I would usually put where is payload? For the payload, payload fairing on here. That is going to be 2 meters as well, and then put the fairing on later, but place it here already. Looking at the missions we have ahead, I'm also going to take this one. So we need a solid booster, and on that solid booster, there's going to be another probe core. That's going to be a science probe only. It's going to go with like 8,000 probably of electricity. There should be enough. It's a little bit too big in my opinion, so let's dial it down here, tidy it up a bit so it looks a little bit better, and then like this, and then we are going to reroute this to our highest stage. Let's double check our staging already so we don't do this at the end of the rocket build. Putting it like this. Okay. So this already gives us a delta V of like 6,700 something, and we are way below those 4 tons, so we can also go like 3 tons now. Libraries is to fit. Still have a little bit more weight efficiency here. Put that in, so that's going to be our upper stage, and then we still need the booster stage. So in my case, I would use like the hollow interstage coupling 2 meters, move this up to do precise movement. Rebel engineer is kind of like screwing with me right now, but just do the degrees to continuous, and then you can just slide them up here so it fits nice and neat. The next thing would be to get our booster stage on here. I usually go with something that resembles like a Thor rocket. So I'm gonna put the tank on here. 3 meters in diameter, and the engine's gonna be the LR79. And now something comes up for the scalability that I usually use. So let's fill this up already and get us a launch clamp on here just so it shows up in the calculations, the proper calculations. So right now we need to do this nice and neat. Going for the nose, it's going to be a 3x2, so going from 3 meters to 2 meters. Quick math. And then we'll try to fit this so it works with the engine's burn time. I'm going to overburn those engines a bit, but we also have to make sure, because the first engine is quite weak compared to the other ones. So we have the S3 engine right now that gives us about like 670 kilonewtons of thrust, while the other one already gives us about like a little bit more than 10% more thrust, which also means it burns more fuel. So, and that's where tooling comes into place, and this is where it's going to be a little bit important later on if you plan ahead. Because, look at this again. The next engine is actually at the 1958 orbital rocketry node. It's the next one we're going to research. We're already at the 1957 one. So this engine is going to come up fast. It's going to improve the engine thrust. It keeps the rated burn time equal, and the efficiency of the engine, the specific impulse, is also identical, which means this thing is going to carry more in the first stage. A bit, but it's going to carry more. So what I usually do then is, for the first stage, I set it up with the tank size already in place to support the burn time for the next engine, and then I just reduce the amount of fuel I have in there. So let's switch to the S3D engine. Get the fuel in here. So we're already at 2 minutes. I think it's going to burn like 3 minutes. So usually I'm going to go like 320 or something. So let's increase the length until we hit like 3. That's already like 320. Okay. We also need attitude control or roll control. So for this, we do need the Vernier engines. Let's get to 90 degrees. Where is it? 90 degrees. So 2 of those in as well. So the rocket doesn't roll uncontrollably. And once we've done that, so it's 3. We can already see that this rocket is missing something. So we do need an avionics package as well for this. It's going to be 2 meters. It should carry about like 60 tons. We have a 60-ton pad already. 800 is enough. Resize to fit. Put it on. And now we can see that our delta V is like something like 12,950. But this is not the rocket we are going to use first, because we don't have that engine yet. So the next thing I do is just go back to the S3 engine, the one we already have. And then we can see, if we remove the fuel again, put the proper fuel in again, fuel mixtures, well, it's actually the same fuel mixture. We see that we're like up at 330, but the sea level thrust is 104. So that's not really going to lift off at all. What we could do is we could go with, in such cases, you could go with solid engines, but we don't have any yet. the Castor engine is coming up. We're going to use this in the playthrough to increase the capacity of this rocket, but right now we don't have this. So that's a little bit too much to get this rocket off the ground. So we're just gonna reduce the utilization here until we get like 320. So 110. 110 is okay-ish. We're still at 12,800 of delta V. And that rocket should do enough to get us where we need. I'm going to tidy this up. I'm going to create a nice launch pad for this, and then in the next episode, we will see on how to actually tackle those missions. But those are the first step to get you started and rolling, because now you have a launch vehicle that is capable of performing enough maneuvers. We do have one unguided stage, the top stage. It's unguided and it cannot control the burn. It's just a solid rocket motor that just burns out. So we will see how we utilize this using MechJeb in the next episode. But for now, we just have the rocket and everything we need. The next step, having that rocket, is to modify the launch pad. So the launch pad carries enough fuel. So usually just click modify and modify. And those engineers have been set to modify. So that's our rocket 1 we built. Let's save this real quick. We're going to leave. We have everything we need to finish those missions once the rocket. So, where are we now? Our rocket is being built. We know the missions ahead. We do have a rocket system that is capable of accomplishing all those missions. We set up our administrative program. We did set up our staff. And just looking at the missions themselves, we will see that once the mission comes up, and that's going to be in the next episode. So, well, yeah, thanks for watching, and I'm going to probably have episode 2 immediately uploaded after this one, so you can actually watch those rockets do the missions themselves in a minute. See you in the next video. Have a good one.